I want to talk about some vocab that we're going to need be able to use for the rest of the year to describe graphs and also mathematical relationships in general. So when we did the question of the day to sort of predict what that graph of circumference as a function of diameter for our circle lab would look like, Mr. Orsted talked about how we were going to get something that looked like, I'm just going to write this down on a piece of scratch paper. You do not need to write this down because it is already in your notes. Something we know that as the diameter gets bigger, the circumference got bigger, and so, but we didn't know the way that could happen. So it could be that maybe it looks something like this, maybe it looks something like this, maybe it looks something more like that. We don't know. But we were able to figure out or predict or at least try to make sense of that as something circular got wider, as its diameter got bigger, its circumference, the length around it, would get bigger. And any relationship that does this, as one variable gets bigger, the other gets bigger, we can call a direct relationship. And so any one of these is an example of a direct relationship. So direct relationship, just like this, as one variable gets bigger, so does the other. As the x value gets bigger, the y value gets bigger. The y value. And the opposite would be true as well. As the x value decreases, so does the y value. And so then what's the opposite of a direct relationship? What do we call a relationship where as the x value gets bigger, the y value gets smaller? That has two different names. Both of them are okay. We will use them sort of interchangeably, and you're welcome to use either one or both. You just need to recognize that both of them mean the same sort of thing. It could either be called an indirect or inverse. Okay, those are synonyms. An indirect or inverse relationship means that as the x value increases, the y value decreases. So one value gets bigger, the other one gets smaller. You can also think of it in terms of like as x gets smaller, y gets bigger, or as y gets bigger, x gets smaller. The two variables are just going to be changing in opposite directions. So any sort of relationship is going to be one or the other. It's either going to be direct or indirect. But then, like I said, these are all examples of direct relationships. We want a way to describe in more detail, the exact shape. And so as we go through the year, we'll go into more and more detail. We want to avoid using mathematical words that we're not actually sure if they are completely correct, though. For example, this kind of curve. Some people might look at that and they might remember from math class the word parabolic. And they might want to call that a parabolic relationship, or they might want to call it an exponential relationship. Well, it could be parabolic or it could be exponential. Both of those are very specific things. If it's parabolic, it's not exponential. And if it's exponential, it's not parabolic. And it could be something else as well. There's lots of relationships that are curves, and unless we know exactly what it is, we don't want to just start misusing math terms. And so at the simplest level, we can at least divide this into two general shapes. Either the relationship forms a straight line, like this, or it forms some sort of a curve. And we call those either linear or nonlinear relationships. So, direct relationship, indirect relationship. A linear relationship means that the graph forms a straight line. and nonlinear. The graph forms some other shape. Nonlinear relationships are generally going to be some kind of curve. But we don't want to overuse or misuse specific words for specific types of curves, like parabolic or exponential, unless we actually know for sure that is the relationship. And so when we're just starting off, we can just say it's either linear or nonlinear. So we'll just do a little bit of practice maybe. Let's say that I had a graph that looked like this. I want to know, how would I describe this? So go ahead and pause and think about which words you would use to describe this. You can pause the video and then hit play when you're ready. Okay, so we can see that this relationship, as our x value gets bigger, our y value is also getting bigger. So if we start here, little x value, little y value, go to a bigger x value, we have a bigger y value. And so that is a direct relationship. And we can see that it's not a straight line, and so it's a nonlinear relationship. And so the way that we could say that in words is this graph displays a direct, nonlinear relationship. And we would actually want to say what it's between if we actually knew. And so let's say that this was, whatever our x value is. This is our y value. We could actually be more specific. This is a nonlinear relationship between x and y. Let's try one more. Let's say we have something that looks like this. And let's, instead of just calling it the x and the y variable, let's just make up some nonsense words. These will be zots, and these will be zips. Go ahead and write the corresponding statement directly underneath, how we would describe that. I'll give you a chance to pause the video, write your statement, and then hit play when you're ready. Okay. So we would say for this one, this graph displays so if we look at our starting x value, it's got a pretty big y value. Go to a bigger x value, we've got a smaller y value. So as our x value gets bigger, our y value is getting smaller. We said that's either indirect or inverse. You can use either word, your choice. So this graph displays an indirect, or you could have said inverse. Equally good. Relationship. And we can be a little more thorough than that. We can say what it's between, in this case, zots and zips. Oop, sorry, I forgot the shape. So the other thing we need to talk about is if it's linear or nonlinear. And so this is forming a straight line, and so we would say it's an indirect linear relationship. Between zots and zips. And when we are doing preliminary lab analysis or making predictions, this might be all that we're initially able to come up with. We might either look at some data or predict what some data is going to look like, and if we wanted to describe it in words to someone, just like we would use numbers to describe how big something is, if you want to either describe a general relationship you found or predict one, you can use this language to describe what you're seeing in the lab or what you expect to see. And this is something that we might expect you to write for some of your labs, either as part of the prediction or as part of your results section to describe what you found.